In our next unit, we're going to start talking about similar polygons. So similar polygons act just like similar triangles. So we're going to take a couple seconds to review them. So if we look at these first examples, not highlighted black, that probably would not be ideal. If I look at these first examples, how do I find missing sides when I have two triangles that are similar? So notice I have the question mark there. So if I label that x, does anybody remember what I do to solve for x? Well, I have to set up a proportion. I do little over big. So little triangle over big triangle equals little triangle over big triangle. So if I look at side 28, that's on my little triangle. 28 corresponds to what side on my big triangle? 42. And that equals my other little side, which is x over x corresponds to 33. So when I cross multiply, I have 42x equals 28 times 33, which is 924. So now if I divide by 42, what does x equal? Well, it equals 22. So all I'm doing is setting up a proportion when my triangles are similar. If I look at the next one, notice I have triangles that are stacked on top of each other. So this is where I usually highlight my little triangle just so my brain can see it. So if I highlight my little triangle, it's right here. So, and I'm looking for x, which is one of the sides of my big triangle. So since I'm looking for x, what does x correspond to on the little triangle? Well, it corresponds to 0.9. So I'm going to do 0.9 over x just to make sure that I get x in my proportion. And then if I pick any other side, what's another little side of the triangle you want to use? Well, let's use 3. Well, 3 is this side of my little triangle. So 3 corresponds to this whole side, which is 4.5. So now to solve, I'm going to cross multiply. So I have 3x equals 0.9 times 4.5, which is 4.05. And if I divide by 3, x is going to equal 1.4. So hopefully you've remembered how to solve a problem when you have two similar triangles. So today I'm really doing something very similar. It's just with polygons. It just has more sides than just 3, but it's almost the exact same. I'm going to go ahead and cross out number 3 because I didn't type all of the right instructions in there, so it doesn't really work. So let's go ahead and let's talk about what it means for something to be similar. In order for a polygon to be similar, two things have to be true. What are those two things that have to be true? In order for something to be similar, what has to be true? Well, all corresponding angles are congruent, right? All my angles have to be congruent. What about my sides? If my triangles are similar, my shapes are similar, the sides have to be congruent? No, because that would mean they're congruent. However, all corresponding sides must share a common ratio. All corresponding sides must share a common ratio. Another word for common ratios is just scale factors. And another way to think about this is a similar polygon is just a dilation. I took one image and I dilated, like we just did on that last unit. I dilated this big triangle to be smaller, so I have to have a scale factor. I have to know what that scale factor is. So the hardest part is how do I find the scale factor? How do I know if it's going to be, usually your scale factor is either a whole number if it's getting bigger, or it's a fraction if it's getting smaller. So if we write that down as my first conditions, I have two conditions. So if my scale factor, let's call if my scale factor is less than 1, which means it's a fraction, are you going from a big shape to a small shape, or are you going from a small shape to a big shape? Well, since it's a fraction, that means you're dividing, so that means you're going from big to small. What about if my scale factor is greater than 1? Well, that means it's getting bigger. I'm multiplying by numbers, so that means I'm going from small to big. So sometimes it's hard for us to remember which way to go. So I have this fabulous just phrase that we're always going to say. My scale factor is always written in the same way. It's always written as scaled over original. You're going to hear me scream this a lot because that's how I write a scale factor, is it's scaled over original. I put my scaled image on the top, I put my original side on the bottom. That's how I get my scale factor. So if I go down here and I look at this, it says determine if the following polygons are similar. If yes, state the scale factor from the small figure to the big figure. So let's go ahead. In order to determine if something's similar, we just have to set up proportions. So 7 corresponds to 14, so 7 over 14, 9 over 18, and 5 over 10. And if I simplify all of that, I get 1/2, 1/2, 1/2. So yes, it works. So here's the kicker. And when we were learning this with triangles, similar triangles, I told you it didn't matter which way you wrote your common ratio. Now it matters. Notice it says I'm going from the small figure to the big figure. So the small figure is where I'm starting. So I'm going to put a star in my small figure because that means that's my original. Or if you don't want to put a star, you can put an O because that's your original figure, which means your big picture is your scaled. So how I get my scale factor is I do the scaled side. I'm going to do the scaled side over the original side. So since this picture has the S for scaled, I'm going to pick any one of these numbers. It doesn't matter. So let's pick 14. So scaled is 14. So it's going to be 14 over my original. So what does 14 correspond to on the original figure? 7. So it's 14 over 7, which equals 2. So I would write yes, it's similar. My scale factor, just write SF, equals 2. If you were to tell me my scale factor was 1/2, that would be wrong because I'm going from the small figure to the big figure. So another way to think about it is if I'm starting at the small figure, how do I get to the big figure? Well, all I have to do is multiply by 2, which is why that's my scale factor. Sometimes it's not as easy to see the scale factor, which is why we just remember scaled over original. So if I look at this next one, first I want to see if it's similar. So 18 over 6 and 15 over 5. So 18 over 6 and 15 over 5. That makes 3 and 3, so yes, it is similar. So now we have to determine the scale factor. So how I determine the scale factor is I do scaled over original. So my small figure is still my original, which means my big, since I'm starting at the small and going to the big, that's my scaled. So now I just pick any side. 15 over the original, 15 corresponds with 5, that equals 3, so my scale factor is 3. And let's try one more down here. If I set up all my ratios, little over big, little over big, little over big, and so on and so forth, I would have 2 over 4 and 3 over 6 and 4 over 8 and 5 over 10 and 6 over 3. This is 1/2, this is 1/2, this is 1/2, this is 1/2. 6 over 3, that's not 1/2, so they're not similar. Go ahead and let's look on the next page. So here, I'm just telling you that these are similar, and I just want to know what the scale factor is. So scale factor here, I'm going from figure 1 to figure 2. So since I'm starting at figure 1, that's my original. And since I'm going to figure 2, that's my scaled. So how do I write the scale factor? Well, it's scaled over original. So since this has the S, pick any number you want. So let's pick 2. 2 over 2 corresponds with 8. So my scale factor is 1 over 4. So go ahead and pause this video and I want you to try the scale factor of this one on your own. So figure 1 is your original because that's where you're starting because it came first. Figure 2 is your scaled. Find your scale factor. When you finish, we will go over it. So if you look, figure 1 is my original, figure 2 is my scaled. So I'm going to do scaled, which is 12, over my original, which is 4, which equals 3. So my scale factor is 3. If you had to pick 9 and 3, you get the same answer. And if we look at this, just so we can think about making sense, if we go back to the first example, going from figure 1 to figure 2, it's getting smaller, right? So since my figure is getting smaller, my scale factor is going to be a fraction. And if we look at this one, figure 1 to figure 2, it's getting bigger, which is why my scale factor is a whole number. So now, let's look at this guy. It says, when given a scale factor, how do I find the missing side? So when I'm given a scale factor, how do I find the missing side? Is I set up, let me not write in highlighter, that would not end well. All I do is set up a proportion, always starting with the scale factor. So when I set up a proportion, I always start with the scale factor. Then I have two conditions. My smaller number relates to smaller shape. And my bigger number, I'm just going to write big number, relates to big shape. So let's go ahead and talk about how I would do this. It says if ABCD is similar to JKLM and has a scale factor of 1/2. So I see that it has a scale factor right here. So I know I'm starting with that. I want to find JK, JL, ML, and JM. So let's find JK first. I'm going to put an X on JK. So how I set up a proportion is I always start with my scale factor, so 1/2 equals. Now if you look at 1/2, where's my smaller number? My smaller number's on top, which means my small shape's going on the top and my big shape's going on the bottom. Because I know this is going to be another fraction. So if I look at these two, X corresponds to 8, right? So I have to ask myself, okay, X, is that on the small shape or the big shape? Well, that's the small shape. So since you said the smaller number was on top, that means my smaller shape has to stay on the top, so X is going to go on the top. And since my bigger number is on the big shape, my big shape is 8. My bigger number out of 1/2, 1 and 2, 2 is bigger. 8 goes on the bottom. Cross multiply, I have 2x equals 8, so x equals 4, which means JK is 4. So let's find KL. I'm going to label that y. So I'm still starting with the same scale factor, 1/2. But now I have to look at it. Y. Is y on the small shape or is y on the big shape? Well, y is on the small shape, so now I come to my scale factor. Where's my smaller number? It's on the top, so y goes on the top. Y corresponds to 6. Bigger number goes at the bottom. Cross multiply, I have 2y equals 6, so y equals 3. Now I'm aware there are some of you that are saying, well, I don't need to do the scale factor or set up this proportion because I can just do it in my head. And that's awesome. However, they're not always going to be nice that way, which is why I'm doing it this way. If I look at ML I'm going to call Z. So I start with the same scale factor, 1/2 equals, now look at Z. Is Z on the small shape or the big shape? Well, it's the small shape, so small shape goes on the top because the smaller number's on the top out of my scale factor. Z corresponds to 11. Cross multiply, I have 2Z equals 11, so Z equals 5.5. So ML is 5.5. And if we do one more, I'm going to do W, which is JM. So set up my scale factor, 1/2. W is on small shape or big shape. It's the small shape, so it goes on top. And what corresponds to W is 6. Cross multiply, 2W equals 6. So W equals 3, so JM equals 3. So if we go and we do this one together, it says given the following similar figures with a scale factor of 2/3, so I'm going to highlight that because that's important. Find the value of x. So I'm going to set up a proportion. Always start with my scale factor 2/3. Now I look at x. Is x on the small shape or the big shape? Well, it's the small shape. So now go back to your proportion over here. Looking at your scale factor, where's the smaller number, top or bottom? Well, it's on the top because 2 is smaller than 3. So since x is on the small shape, it goes on the same side as the small number. So x goes up there, and x corresponds to 9. So cross multiply, I have 18 equals 3x, so x equals 6. So I want you to go ahead and do this last problem on your own, and when you finish this problem, you should get the same answer as me, and then you're all finished. So when you finish, you should get x equals 16. But go ahead and make sure that you understand how to do this problem, because next class we'll continue talking about it.